P and Q are the midpoints of the opposite sides AB and CD of a parallelogram ABCD. So we are looking at a parallelogram. Property of a parallelogram: sides, opposite sides are equal and parallel with regarding to angle. Opposite angles are equal. Diagonals, they bisect each other, but they are not of equal length. They need not be of equal length. Area is given by base into height. So always recall what we are dealing with and then proceed to figuring out the answer. If you don't know the properties, don't attempt such questions. So we have something like this, and I think that looks okay. Yeah. So what we have here is a parallelogram ABCD. With respect to A, B and CD, we have P and Q, they are midpoints. So when I join them, by default, it will be parallel to this two actually. Anyways, let's see. AQ intersects DP. Okay, did I take it wrong? No, it's correct. AQ intersects DP. Yes, okay. So we have AQ intersecting DP at S. So that's our S. Then BQ intersects CP at R. So this two also needs to be joined. And this is R. Show that PQ PRQS. So basically, I'll just mark it off. It makes it convenient. This is a parallelogram. Okay, so this is parallel to this, and this is parallel to this. So how will we go about doing this? Remember, this is a midpoint and we can make use of that and prove things. Okay, so we are looking at, this is the midpoint, this is the midpoint. I don't have a triangle in that manner. Okay, so how will we go about doing this? Well, this is equal to this, and this would be also equal to this is parallel to this, right? Yeah, these two are equal. End of it, we have to prove that only actually. So anyways, okay, I think I got it. See, BP is by default parallel to DQ because it's opposite sides of parallelogram. Okay, and then we have, what else was I thinking? We have oh yeah, since they are midpoints, these two lengths are also equal. That is, if this is x and this also will be x. Since the opposite sides of PDQB are equal and parallel, thus making it a parallelogram. Similarly, this two will be a parallelogram. Okay, so let me show this. Since the opposite sides are parallel and equal, it's a parallelogram. Okay, something like this. So this is a parallelogram. Similarly, we can prove that this is also parallelogram. We can just write similarly, we can prove that this is also parallelogram. And since we have this set of lines to overlap this two, so we have this line, it's not visible, right? We have this line, or let me use a brighter one. We have this line which is parallel to this line. Okay, so we have this being parallel to this. So because the opposite sides are parallel to each other in quadrilateral PRQS, it's a parallelogram, as simple as that. Right guys? So again, this is a property purely on parallelogram. So we have to show or prove the following, that is PQRS is a parallelogram. Now the proof. So we'll consider this in quadrilateral P PBQD. What do we have? We have PB parallel to QD. These are opposite sides of parallelogram. Okay, then what else do we have? We have PB is equal to DQ. PB is equal to DQ or QD. Reason being because P is midpoint of, actually we have Q and P. Because Q comma P are midpoints of AB and DC, right? And we have AB is equal to DC, as they are opposite sides of, yes, a parallelogram. And therefore we have these two lengths to be equal to each other. Okay, so from above two statements, what can we conclude? From above statements, we can tell that PBQD is a parallelogram, right, as the opposite sides are equal and parallel. Okay, then we can tell similarly we can prove APCQ to be a parallelogram, right? And now the conclusion. So we have BP parallel to, sorry, not BP, as BPQD is a parallelogram. What can we conclude? Actually, I could have written it over here itself, but I'm just going with the flow. CR is parallel to SQ. CR is parallel to SQ. They are opposite sides. We need not explain that much. Then we have APCQ, this one, and APCQ is also a parallelogram. So with this we can tell that PR is equal, yes, sorry, not that, I think that only. PR being parallel to SQ will come from here. CR, what is the point of writing CR is parallel to, no, my bad, this is not required. And that's not true also. We have SR is parallel to, my bad, this is wrong, SR is parallel to QR is what we have to write over here. And over here we have PS parallel to QR. PS parallel to QR. Okay, so these are opposite sides of parallelogram. I know I just told not to, but I don't know, I just felt like by chance if they want to cut marks, you should not give a chance. To be honest, not required actually. We have already explained it. Wait, let me just look at what we have written. Opposite sides of parallelogram. Okay, not required. Okay, so such reasoning we have already written it, so we are done. Okay, at last what can we tell? So from 1 and 2, so we have from 1 and 2, what do we have? We have P, array, that's the problem with having the diagram in a different sheet. PRQS is a parallelogram. Here we need to explain why, as opposite sides are parallel. Okay, right? So yeah, it's a bit of confusion because of the diagram being over there. I could have copied it, I should have. So that's the importance of writing a lengthy answer in a single sheet, or at least on the left and the right side, you know, the same set of sheets. I hope you guys are understanding what I'm telling. In a booklet, you start the answer on the left corner, so that if the answer goes a bit longer, you have enough space and you are looking at the diagram to write it on the right hand side. And whatever space is left, you can just scratch and move on to the next page.